All right, let's go ahead and move forward. I want to talk about triangles. You guys will need out that table that had all the properties on it. You'll need that out. And we're going to kind of go over this diagram one more time, talk about the quadrilateral hierarchy. Okay. Mackenzie, what shape is all the way up here at the top?
Hang on, I'm going to go up. Okay.
All right, good job, Justin. Okay, so it's quadrilaterals. What's our center shape? Mackenzie?
Parallelograms.
Parallelograms. Sebastian, give me one of my two outliers. Huh?
Right.
Give me either this shape or this shape.
I can't see.
Then move closer.
I need to move a lot further.
Why do you wear your glasses?
It broke.
Oh.
No, I don't know.
Don't miss me. I just want you forgot.
Sean? Trapezoid. Very good. So you have trapezoids. Ivan, give me this other one. Heights. Okay, now I want to go under the parallelograms. Spencer. Parallelograms get subdivided into two other categories. Give me one of them.
Rectangle.
Rectangles. That's today's lesson. Okay, and what's the other one? Rhombus. And then finally, all the way at the bottom, is a square. Now, based on this, I have a very basic question. If a rectangle is a parallelogram, correct?
Correct.
Then what does that imply about the properties of rectangles?
Has the same thing as parallelograms.
Has the same properties as parallelograms. Okay, so that's really important. So we look at this. There's one more thing I want you guys to notice. This is where your chart comes into play. Remember that table you guys printed off for you guys? You're going to put all the X's in.
Yep.
You're automatically going to fill in for rectangles, all the same properties, parallelogram, and then one more. The diagonals of a rectangle are congruent. Therefore, AC is congruent to DB. And you guys already showed that on the final exam from term 3. So that should not be something new to you. I don't know. That's up to you guys to do. Now, one reason why you really want to stay up with that table is because you can use that on the test on Monday, a week from today. So you want to make sure that table is filled in. Okay, let's review very quickly. What are some of the things that rectangles inherit for parallelograms? Somebody give me one of them. Yes.
Both pairs opposite sides are parallel.
Both pairs opposite sides are parallel. Good. What else? Corbin? Has 4 what? That is not something that comes out of the parallelogram. Okay, so what else do we know? Justin? Diagonals bisect each other. Very good. Got this one there. And actually, we'll just go ahead and fill it in. So, right, these are the 5 things that you should have on the parallelograms. Opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. The diagonals bisect each other. And consecutive interior angles are supplementary. So, we get those 5 characteristics just out of being a parallelogram. And then, like we said, then you get some extras because you are a rectangle. As Corbin said, one of the extras is that you have 4 congruent angles. Okay, that's one of the things that makes that an extra rule for a rectangle, 4 congruent angles.
Can you leave that? It's because the first 2 are
And that might be all you guys will have.
It's like one from one now.
Yeah, we're not beyond that table.
which one?
Should be number 5. Second interior angle or something.
Oh.
Okay. Okay, let's go ahead and move on to here. So like I said, we're adding two more properties for being a rectangle. One is that it has 4 right angles. So that means all the angles in a rectangle are right angles. Okay, so that's something special about a rectangle. It has 4 right angles. And the diagonals are congruent, so like we said, therefore AC is congruent to BD. In fact, one of your homework questions tonight will be, tell me if A, B, C, and D make a rectangle. Easiest way to do that is to verify that the diagonals are congruent. Every time that if you're dealing with coordinates and it asks you, is this a rectangle? All you got to do is see if the diagonals are congruent. If it is, it's a rectangle. If it's not a rectangle. So this is true if and only if it is a rectangle. All right, so let's go ahead and put this to use. Example 1. All right, we're told that AC is 2x minus 8 and that BD is 23. First of all, what property are you going to use to solve for x? Which property applies?
The diagonals are congruent.
Okay, yes, AC is a diagonal and BD is a diagonal. We know that if this is a rectangle, that the diagonals are congruent, therefore AC is equal to BD. AC is 2x minus 8, BD is 23, and you can solve for x from there. All right, I want to look at example 2. AB is 4x minus 13, and CD is x plus 7. Which property allows you to set up an equation for this problem?
Opposite sides are congruent.
Opposite sides are congruent. Therefore, AB is equal to CD, so 4x minus 13. Now, number 3 is going to be a little tricky. So DE is x plus 7, and AC is 3x plus 8. Which property will you use? Diagonals are congruent. And what else? There's another one.
You gotta.
Why?
Because you only have half of it.
How do you know it's half of it?
Because the whole line's DV and you only got DE.
Because the diagonals bisect each other. So they do 2 things here. Not only are they congruent, but they also bisect each other. So therefore, twice of DE is equal to AC. So 2 times x plus 7 equals 3x plus 8. By the way, in your homework when you're doing these, you will have quadratic equations that you'll need to factor. Okay, so you might need to find somewhere online that reminds you on how to factor. All right, let's go into here. We have another rectangle. Now we're going to look at this from angle perspectives. If angle 1 is 70, angle 1 is 70, what's the measure of angle 2? Nope.
7 minus 90, 20.
So we have 1, 2, 3, 4,
Angle
5, 6. Yep. All right, so where you said is 20?
Yeah.
Why is angle 2 equal to 20 degrees?
You take 90 minus 20 or 70.
Very good, right? We know that the whole angle is 90. 90 minus 70 gives us 20. What is then the measure of angle 5?
7. No. Can't 7. It would be 70. Because it's the opposite interior.
Yeah, going back to our third unit, right? Parallel lines and transversals. You get an alternate interior angle. This angle and that angle become alternate interiors. So angle 5 is 70 degrees. What does that make angle 6?
20.
9 and 10.
Are you sick?
A little bit. All right, here we go. Number 5, angle 9 is 125. How do you figure out 6, 7, and 8?
Well,
180 minus 1.5.
Okay, now slow that down a little bit. You said 180 minus 125 and divide that by 2. Why would you do that?
Because it's a isosceles triangle.
How do you know it's not a isosceles triangle?
The
Yeah, if they are congruently bisect each other, that means that each one of these 4 parts must be the same length. That means that this triangle then is an isosceles triangle, which means that angle 6 is equal to angle 7. So, angle 9 plus angle 6 plus angle 7 has to equal 180, so you could say,
Okay, so 6 and 7
nope. So now that gives us 2 times angle 6 plus 125 equals 180. So 2 times angle 6 is 55. That means that angle 6 is 55 halves. Okay. Which means that angle 7 would also be 55 halves. Well, what does that make angle 8? What would angle 8 be?
you would have to do 55 times
Nope.
not divided by subtract.
Subtracted from what?
90.
From 90, okay. So we get 90 minus 55 halves.
Yep.
180 halves minus 55 halves is 125 halves. All right, and we've already kind of talked about this one here. This is our last slide I want to go over with you guys. Remember that in order to determine if it's a rectangle, what do you have to verify? Make sure the diagonals are congruent. So to plot out A, B, C, D, all you need to verify then is that your diagonals are congruent. Okay, that's our big concept. All right, so in order to know if it is a rectangle, you just verify that the diagonals are congruent. Okay, that's it.
I'm sorry.